Hello students, this video is in continuation to the part 1 video which was about MCQs on the topic rectangular waveguides. I covered few questions in that video. So in this video I'll be covering few more questions on rectangular waveguides. Question number 1. TE mode is characterized by EZ equals to 0, HZ equals to 0, EX equals to 0 or EY equals to 0. The answer to this question is EZ equals to 0. How? We can see in the explanation. I have made a coordinate system where Z is the direction of propagation. And by definition we know that electric mode, when it is transverse to the direction of propagation, it is called as transverse electric mode. Here the direction of propagation is because z-axis means there will be no electric component propagating in the z direction. So there is no electric field in the direction of propagation, that is z. Hence we take the first option, which is Ez equals to 0. We can be sure of HZ, EX or EY. Hence the correct option is Ez equals to 0. Question number 2. The intrinsic impedance of free space is 50 ohm, 377 ohm, 73 ohm or 83 ohm. The correct answer for this question is 377 ohm. Explanation is, as we know the formula for intrinsic impedance, root of E upon H, and we have calculated this thing already, which is equal to 377 ohm, also equal to 125. The options like 50 ohm or 73 ohm, they are basically the impedances of coaxial transmissions line. Right, so whatever coaxial transmission line, usually they are available in market, they are having impedances 50 ohm or 73 ohm, whereas free space impedance is 377 ohm. Question number 3. A rectangular waveguide is. So what is a rectangular waveguide? Options: resonant circuit, high pass filter, low pass filter or band pass filter. The correct answer is high pass filter. How a rectangular waveguide is a high pass filter? Explanation we can see. As we all know that the criteria for wave to propagate through a waveguide is that the operational frequency f should be greater than the cutoff frequency fc. Means anything above fc will be allowed to propagate and any frequency below fc won't be propagated. So waveguide this way can be thought of as a high pass filter. We all know that a high pass filter is the one which allows the higher frequencies above fc to pass through it. So that is why rectangular waveguide is also called as a high pass filter. Next question. In rectangular waveguides, which of these relations is correct? Vg Vp is equal to V naught square, Vp Vg is equal to 1, Vg into Vp is equal to twice of V naught square, Vg is equal to Vp. The correct answer is Vg Vp is equal to V naught square. This is a straightaway relationship we have derived. Vg Vp is equal to V naught square, where Vg is group velocity, Vp phase velocity and V naught speed of light, 3 into 10 raised to power 8 meters per second. Last question. A hollow rectangular waveguide cannot propagate TEM waves because, first, because of the existence of only one conductor, because of the losses caused in it, because it is dependent on the type of material used, or none of them mentioned. The answer is because of the existence of only one conductor. You can see diagrammatically I have tried to explain two things, how the things work in a single conductor, which is a waveguide, and how the things work in a coaxial cable, which is a two conductor medium. So in the first figure you can see I have written only one metallic conductor. Because of one conductor, the only possible modes are transverse electric and transverse magnetic. Whereas in a medium which is having two conductors, I have mentioned number 1 and number 2. That is why called coaxial. All the three modes are possible, that is TEM, transverse electromagnetic, transverse electric, as well as transverse magnetic mode. Right? So the correct option is option number A. So these are the questions which I have tried to cover up regarding the topic rectangular waveguides. You can practice more such questions. Good luck.